Okay, students, we're going to go over a review of quarter one, Algebra 1. So what I've done here is I put up any quiz or tests that we have done. These are just different numbers than the ones you actually did on the quiz. So I'm going to work out every quiz and test. And then the last thing is the solving systems by graphing and elimination that we ended the quarter on. All right, number one, fractions, multiplying fractions. First thing I can do is deal with the negatives. I have three negatives, 1, 2, 3. So that means the final answer is going to be negative. Anytime there's an odd number of negatives, it is negative. You could have also said negative divided by negative is a positive. So I have a positive times a negative is a negative. The next thing I'm going to do is cross cancel. I look at how many times. 9 goes into 72, goes in 8 times. 9 goes in 9 once. 4 goes into 24 6 times, and into 4 once. So I have 8 times 6 is 48, divided by 1 is negative 48 there. I'm just going to go ahead and go across and work our way down. Okay, so here we're going to use distributive property. Remember, we're solving equations. We're usually looking at distributive property first and then combining like terms. So now I have 10x minus 50 plus 14x equals negative 10 plus 8x. Notice I wrote plus 8x because a negative times a negative is a positive. Get it down to one sign. Usually after distributive property, you're looking at combining like terms. We have like terms right there, both constants I can put together. So now I have 10x and negative 50 plus 14 is negative 36. And there's no combining like terms on this side, so I just write it down again. My next question I ask myself is, which side should I bring the variables to? I always want the variables to go to the larger side. So 8 is smaller than 10, so therefore I'm going to subtract 8x across. And I get 2x, which means the variable is going to the left side. The constant needs to go to the right side, so I'm adding 36 to both sides to move the constant across. Remember, whenever we move a term across the equal sign, I must do the opposite operation. And remember, terms are separated by plus and minus signs. So I'm not taking part of a term. If I want to get rid of that 10 from the x, that's part of a term. Whenever I'm taking part of a term, I'm multiplying or dividing. I am moving the entire term across, so it's always add or subtract. So I end up with 10x equals 36 minus 10 is a smart way to say that instead of negative 10 plus 36, which equals 26. And last step, divide by 2, and you get x equals 13. Now, if I want to check, which I'm not going to do, but if I want to check it, I just take 13 and plug it into the x's in the original equation, and then it would be true. All right, number 2, least common multiple, LCM, least common multiple. That's also what you're finding usually when you're doing the common denominator. So I ask myself, does 4 go directly into 14? No, it doesn't. Okay, so then I'm going to go ahead and double 14 to 28. Does 4 go into 28? Yes, it does. So there's my least common multiple. Obviously, 14 goes into 28 because I doubled it. So if you're not having to go that high, that's the easiest way to do it. But you can also, if you wanted to, take the prime factors. So that's a 2 and a 2, and that's a 2 and a 7. I have to take the most of any of the numbers between the two sets. So notice I have 2 2's here and only 1 2 there. So I have to take 2 2's. And so that takes care of the 2's, and then there's only 1 7 left at all. And so I write down the 7, and 2 times 2 times 7 is the 28. All right, number 3. We are subtracting here. I have 2 1/5 minus 1/5. Okay, let's change that. These are randomly generated. That's too easy. That's just 2. Let's change this to 2 7ths. Let's make this 2 7ths instead. Okay, so you actually have to find a common denominator and do some work. All right, so most people will go with changing the mixed number to an improper fraction. How do you do that? 2 times 5 is 10, plus 1 is 11. So I have 11 over 5, and I have minus 2 7ths. Okay, I get myself a common denominator. Common denominator between 5 and 7 is 35. And now I'm making what's called equivalent fractions. 5 times what is 35? 7. So I must multiply by 7 here. 7 times what is 35? 5. So I have to multiply by 5 up here. I get 10. Now, why are you doing that? Because I'm really multiplying each fraction by 1. Okay, 7 divided by 7 is 1, and 5 divided by 5 is 1. So anything times 1 is itself, so that's why it's an equivalent fraction. Now that I have common denominators, I can just subtract their numerators. 77 minus 10 is 67, and the denominator stays the same, 67 35ths. All right, number 7. There are 2 ways to do this. You can distribute and then use reverse PEMDAS to solve it, or I can look that 4 divides right into negative 16 evenly, and that's the much simpler and quicker way. So I get that, and last step is solve for x, add 8 across. So x equals 8 minus 4 is 4. All right, number 4. Multiplying, we're using PEMDAS going down, order of operations, and this is how it should be written. So that's called order of operations, or PEMDAS. I know both names. Okay, and so I do multiplication and division first. So notice I have a multiplication there, and I have a division here. So I must do those first. Adding comes last. So after I get those answers, then I added the 2 fractions together. So multiplying, I can just cross cancel, or I can vertical cancel. I can just not horizontal cancel. So 6 will go into 18 3 times, 2 will go into 4 2 times, and I get 3 over 2. So I have 3 over 2 plus. Now you need to remember that division is multiplication by the reciprocal. So switch those two. So I'm just going to write it up here, 15 and 12. The 4 will cancel the 12 3 times. The 3 will cancel the 15 5 times. So now I have 5/3. Okay, so I have 3 halves plus 5/3. Again, I need a common denominator. We'll go ahead and write it over here vertically. You don't have to, you can use horizontal. 6 is the common denominator, so that means double it. So that's 10, that's times 3 is 9. And now again, I add them together, 9 plus 10 is 19 over 6. Remember, the denominator stays the same. And so there's my answer. 3, if you want to change it to a mixed number, you don't have to. 3 and 1/6. Okay. So 19/6. If 19/6 simplified, I would need to simplify it. It does not. Okay, number 8. How do we solve all equations? Reverse PEMDAS. Not PEMDAS going down. That's order of operation. That's when you have only numbers involved in your simplifying. We're solving for a variable, so use reverse PEMDAS. Start at the bottom and work our way up. Is there any adding or subtracting? Remember, I'm trying to get x by itself. So I've got 2 things with x. I have this -8 constant, and I have the 4/12. Remember, this is all one term right here. Okay. And remember, if I'm moving an entire term across, it's always either adding or subtracting. So here is the entire term I'm moving across over to here. So I'm adding 8. The opposite of -8 is +8. And then I can simplify that 4/12 down to 1/3 x equals 8 minus 6 is 2. Now, I'm not moving the entire term across. I'm only moving a part of a term, this 1/3. That's going to deal with multiplication or division. So when I have a fraction, I just always multiply by the reciprocal. The reciprocal of 1 over 3 is 3 over 1. So they cancel, and I get x equals 6. Again, I can check all of these by plugging it back in. I'm not going to do that to save time. All right, number 5. Negative over negative is positive. Okay, and again, I'm trying to solve for x. I'm getting rid of part of a term, just that 9/5. So it's multiplication by the reciprocal, 5/9. Whatever I do to one side, I do the other side. Okay. And so I get x equals, and 9 cancels with 36 4 times. 4 times 5 is 20. Again, I could plug that in and check, and it would work. Okay, so that was quiz 1. 8 problems. All right, test 1. Now, we were looking at lines, what equations made lines, and we're talking about degrees of polynomials and exponents and multiplication, addition, and subtraction of polynomials. Again, all this stuff is on the DCAS as well. So we have 3 types of lines: horizontal, vertical, and oblique. Remember, oblique, a lot of students like to say diagonal, but the technical term is oblique because a diagonal is actually in geometry when you connect 2 non-adjacent vertices. So if I have a pentagon there, these are adjacent. Adjacent means next to, they're already connected. If I connect that one to that non-adjacent one, because it's not connected, that's a diagonal. That's a diagonal. That's a diagonal, and that is a diagonal. So that's what diagonal means in math. So a line that looks like it's a diagonal, we call it oblique. So now you just learned something about geometry for next year. Okay. All right. So what makes a line for an equation? The exponents on the x and or y or both have to be 1 in the numerator. Okay, and it was 1 in the numerator. If there's both an x and a y in it, such as number 1, with an exponent of 1, which it is, that is oblique. Remember, x is 0 really means 1. So 1 times 1 is 1. That's just a constant now. I can subtract that across. So I have y equals a number when I solve for y. Y equals a number is always a horizontal line. So that's number 1. And again, x is 0 is 1. So I have negative 3 minus that. When I solve for y, I get y equals a number. And that's another horizontal line. If I change this to an x instead of a y, if we want to practice that, that x equals a number is now a vertical line. So that would be a number 2 if it was an x right there. An example, these all came out to be lines. It's randomly generated. An example of a couple that would not be lines. If I had a 1 down here as an exponent. Remember I said that exponent on the x has to be a 1 in the numerator. That's a 1 in the denominator, so that is not a line. Another one would be, instead of it was x is 0, is x squared. No other number, no other exponent besides a 1, okay, in the numerator on the variable. It's on the variable, it has nothing to do with constants. You can have any exponents you want over here. It's on the variables only. Okay, and the last one that would make a line, that's a tricky one, is if I put a negative 1 right here. You think, oh, it's not a 1, but don't forget, negative 1 means inverse or reciprocal. So x to the negative 1 actually moves this to the numerator, and it would become negative 3x minus 6y equals 2. And now the exponents are 1, and I have both an x and a y in it, so that would be oblique. So those are the possibilities that you could have seen on your quiz that we covered in class. Okay, and you'll be asked that on the DCAS as well. I think at DCAS it doesn't break down to horizontal and vertical. It just says, is it a line or a parabola or an exponential, or just just says which one of these below multiple choice are lines. And so we'll get into parabolas and exponentials later. We're just focused on linear in this unit. Okay, number 13, multiplication. I showed you, and I'll show you 2 different ways. I showed you the vertical method, which I usually do. So I just wrote this down vertically, and that's like elementary school multiplication. Negative 8 times 4 is negative 32. Negative 8 times 5x is negative 40x. Now you need to remember to put signs on every one here. Some of you forgot signs and didn't have signs in your answer. It also is completely wrong. You have to have the plus or minus sign. Now I have x times 4 is 4x, and put the plus with it. And then x times 5x is 5x squared. Notice when I do that, I'm lining up like terms. So now I can just add straight down, and there's my answer. 5x squared minus 36x and minus 32. Now the other way, if you don't prefer the vertical method like this, is the box method. Box method, you draw a box, you put the number of terms on the outside. So I have an x and a negative 8 here. That's for the x minus 8. And I have a 5x and a plus 4 right there. and then I multiply the row by the column. So x times 5x is 5x squared. 4 times x is positive 4x. Negative 8 times 5x is negative 40x. And negative 8 times 4 is negative 32. Then I need to remember to combine the like terms, find the like terms in there. And they're usually oftentimes at diagonals like that, negative 40x and then negative 4x. That gives me that negative 36x right there. There's my 5x squared right there, and there's my negative 32 right there. So that's called the box method. So you can choose which one you want to do. All right, 14 is squaring a binomial. Remember this is called a binomial because it has two terms. Bi means two terms in it. You can either multiply it out by one of the two methods up top right here, vertical or box method, or you remember the shortcut. And so I'm not going to multiply it out. I'm just going to show you the shortcut. For those that want to remember it, especially those that want to go into higher math and or want extra credit points in class, when I put it up there for the first one that puts down the answer. Okay, those and raise your hand gets it right. The rule is when I square a binomial, so it's called squaring it because the exponent is 2. 4x plus 7 times 4x plus 7. The rule is I square the first term. 4x times 4x is 16x squared. I then take the two terms, 4x and 7, positive 7 that is, multiply them together and double that. That gives you my middle term. So I have 8x times 7 is 56x. That's the middle term. And the last term comes from just squaring the last term or the second term here. 7 squared is positive 49. And you should remember that anytime you square a number, it's always positive. So the first one has to be positive, comes squaring it. The last one has to be positive, comes squaring it. The middle term could be positive or negative depending on whatever this middle sign is. Whatever this middle sign is going to be the same as that sign right there, just so you know, if you haven't figured that out yet. Okay, number 4. What's the degree of the polynomial? Again, a DCAS question. The degree, by definition, is the highest exponent on any one of the terms on the variable. So there's a variable, there's a variable, there's a variable, there's a variable, there's not a variable. Since there's no variable in this last term, that's called a constant term. Any number by itself is a constant term. So we don't look at that at all because it didn't have an x with it. So I purposely put that there to see if you would choose that one. That's why I made that one the highest one, to see if you pay attention to the definition that it has to be on a variable. So the highest one here is 6. So the degree is 6. Now it says write the polynomial in standard form. Polynomial in standard form means highest degree down. Highest degree down. So obviously we have, and you have to make sure you put the sign with it, negative 8x to the 6th. Next one up is positive 8x to the 5th. Next one is minus 8x to the 4th. Next one is negative 6x squared. And lastly is my constant. That's degree 0. All constants, because I can always write this as 2 to the 7th x to the 0 if I wanted to. So a constant always has degree 0. Okay. All right, so there's that answer. Number 5, the degree. Now, if I have more than one variable, I have to add up all the exponents on the variables to find the degree. Okay, so notice here, I have a 3 and a 4. That's a total of 7 for that term. 2 plus 1 is a total of 3 for that term, and 6 for that term. So I'm going to go in order, highest degree down. The highest degree is 7, so that's a degree. I write down the highest one down, 4x cubed y to the 4th, and I go to the 6th degree, 2x to the 6th, and I go to the 3rd degree, minus 3x squared y. Okay, and there's my answer. All right, 15. Again, I have two binomials I'm multiplying together. You can, every time if you want, do the vertical method or the box method, but again, this one has a shortcut. The reason it has a shortcut is because the 5x and 5 and 5x and 5 are the same. The only thing that is different is one's a plus and one's a minus right there. That is called a difference of squares when we multiply this out. And what that does, that wipes out the middle term. So you notice normally when I square a binomial, I multiply two binomials together, I get a trinomial. That's normal. But there's this one special case where it wipes out the middle term, and so you end up with a binomial, and that's when the terms are the same, and the only difference is a plus and minus sign. So to get that answer real quick, I just multiply the first terms together, 25x squared. Multiply the last two terms together. Negative 5 times positive 5 is negative 25, and there's my answer. So this answer of 25x squared minus 25 is called a difference, and that difference comes from a subtraction sign, of perfect squares. Nowadays, they'll often just call it difference of squares. When I grew up, it's called difference of perfect squares. Because I can take the square root of 25x squared and get a 5x, and the square root of 25 and get a 5. So they're perfect squares. When I have a binomial like this, and there's one of these on the DCAS, when they're going to give it to you, even in interim 1, even though we don't really talk about factoring like we're doing right now until second semester. If you have a difference and you have a binomial, you want to look for difference of perfect squares like this, and you take the square root of each, and that gives you that answer, and that answer square root of each, make one plus and one a minus, and that's how you get that answer. All right, number 6, combining like terms. So like terms means same variable and the same exponent. So there's an x squared. Here's an x squared. So those are like terms. Combine them. This is a negative 8, and that's a negative 4 to give me negative 12x squared. Now, we have people that would add up those exponents and put a 4 in there. Okay? Think of it like this. If I have negative 4 apples and negative 8 apples, the x squared representing apples, I just get negative 12 apples. I don't get apples squared, just negative 12 apples. Negative 4 apples, negative 8 apples would be negative 12 apples. So the apples was at x squared. So the like terms remain the same. You just add the coefficients. Remember, a number in front of a variable is called a coefficient. The next one I look at, x to the first and x to the first. Those two, negative 7x plus 4x is negative 3x. And then lastly, my constants. Remember, we're going standard form, which is highest degree down. I did degree 2 first, then degree 1, and now the constants, which is degree 0. Negative 3, negative 8 is negative 11. You can box. Some people like to put a box around some of them like this, and then they underline another one, and they circle another one for the like terms. So they do that first to make sure that they're picking out all the like terms. Okay, number 7. We have a negative times a negative is a positive. Remember, we have a number outside of parentheses. That means I have to distribute it within the parentheses. So I do that first. There's just a 1 out there, so I can just take off those exponent on that parentheses, because 1 times anything is itself. But over here, I would have 9x cubed plus 18. Okay, notice my like terms, negative 7x cubed and 9x cubed. 9 minus 7 is 2x cubed. Then I have a negative 7x and no other x's, so just negative 7x. And lastly, I have a constant of plus 18. And there's my answer. Combine like terms. Remember, after the distributive property, you're looking to combine like terms. And write it in highest degree down. 3, 1, 0. Constant's always degree 0. All right, number 16. We are multiplying two trinomials together. I'm going to do it the same way as I did up here in number 13 when I had 2 binomials, except for now it's just 3 terms by 3 terms. Okay. I will go ahead and do the box method. This one I don't have room to do both. I'll just go ahead and do the box method this time. Draw yourself a box. It's got to be a little bigger because I got 3 terms this time. Okay. Oops. Get the third box in here. 3 by 3. 4x squared minus 1x and a plus 7. It doesn't matter if I put this on the vertical side or the horizontal. I just put the other one on the other one. So now I have 3x squared minus 4x plus 5. And then I go ahead and multiply row by column. 4x squared times 3x squared is 12x to the fourth. 4x squared times negative 4 is negative 16x cubed. 4x squared times 5 is 20x squared. Next one, I have negative 1x times 3x squared is negative 3x cubed. Negative 1x times negative 4x is positive 4x. And negative 1x times 5 is negative 5x. Lastly, I have 7 times 3x squared is 21x squared. I have 7 times negative 4x is negative 28x. And 7 times 5 is 35. Now I need to find my like terms. There is no other fourth degree term, so that's my answer there, 12x to the fourth. But cubes, I have cubes right there. That's negative 19x cubed. Then I have, oops, I forgot the squared there. X times x is x squared. Notice they're usually in diagonals like this. Then I have x squareds right there. 21 plus 4 is 25, plus 20 is 45, x squared. Then I have my x's, negative 28x, negative 5x is negative 33x. And lastly, I have my constant plus 5. And there you my answer. Okay, so that's the box method. If you like that over the vertical, go ahead and use that. It doesn't matter. Those are the two most common ways. Okay, nowadays at least. All right, now we have a monomial times a binomial times a binomial. When I have 3 that I'm multiplying, I only can multiply 2 at a time. So I'm going to just go ahead and distribute this s through there. I get s cubed minus 2s. And then I have times the quantity s plus 9. Now I could use the vertical method, the box method, or the last method is if I just use distributive property and just go vertical, horizontally across. S cubed times s is s to the fourth. S cubed times 9 is 9s cubed. Negative 2s times s is negative 2s squared. And negative 2s times 9 is negative 18s. Okay. And there are no like terms here, so there's no like terms to combine. So there's your answer. Okay. Where's that little? Okay, there it is. All right, multiply the following. We have a monomial times a binomial, so this is just distributive property. 3x times x, 3x squared. Remember, you add the exponents when you multiply like bases. 1 plus 1 is 2. Then 3x times negative 4 is negative 12x. So I'm doing it again here. Just taking that, distributing it through. That's 6x to the ninth, because again, we add the exponents of like bases, plus 6x to the fourth, and minus 24x cubed. Okay. Now we have cubing. So we have this monomial cubed times itself 3 times. So I distribute the exponent of 3 through each of these. So that would be 4 cubed x squared. When I do a power to a power, you multiply them. So x is 6 and y 5 times 3 is 15. 4 times 4 is 16 times 4 is 64. 64 x to the 6th, y to the 15th. There's my answer. Okay, now we're dividing monomials. Okay, I can simplify this fraction, 8 over 40, simplifies to 1/5. In order to make a negative exponent positive, I can drop it down here. And so I have another x to the 4th down here. So do I have any x's up top? No, I don't. But how many x's do I have in the denominator? 4 plus 4 is 8. And then here, both of them are already positive, so I can just subtract down. I always ask myself and say, where do I have more y's? I have more y's in the numerator, so the y must be there. Well, how many more do I have? I have 6 more, and that's what you get when you do 9 minus 3. When you have these final answers like that, you cannot have more than one x written down and more than one y written down in your answer. Just know that. All right, let's do number 12. Okay, so notice we have negative exponents on the outside. To make the negative exponent positive, I would switch it if I want to make them positive right away. I can also just distribute the negative 3 through here like we did before and do that. Okay, so there's two ways of doing this. So if I do that, let me rewrite it as 7 to the negative 3, x to the negative 24, y to the negative 27, over 3 to the negative 3, x to the negative 21, y to the 9. Now, again, we want to change our negative exponents to positive, and so that means take the reciprocal. So flip it from the numerator to denominator or vice versa. So now if I move it down here, it becomes cubed. That negative becomes positive when I move it up to the numerator, so I have that. Switch those two, so x to the 21st is positive up here and x to the 24th down here. And y to the 27th becomes positive in the denominator, and I already have the y to the 9th positive. I don't switch that one because it's already positive, so it stays where it's at. Okay, so now I can get my answer from here. 3 cubed is 27. Okay, where do I have more x's? In the numerator or the denominator? Denominator, how many more do I have? 3. I have 7 cubed down there. That's 343. You can put it in a calculator. And where do I have all the y's? In the denominator, how many do I have down there? 27 plus 9 is 36. And there's your answer. Exponent rules. All right, 18. We want to cube this binomial. Remember, we only can multiply two things at a time. So I do f minus 2 squared. Remember, to use that shortcut rule, I square the first term, f squared, multiply the two together. That gives me negative 2f. Double that, negative 4f, and then square the last term, positive 4. Again, if you don't memorize that shortcut rule, you would need to multiply out f minus 2 times f minus 2. So you're going to do the box. You have to do f minus 2 times f minus 2, and then use the box method to get that answer. So there's 2 and multiply together, and now I need to multiply it by a third one right there. I'll do the vertical method here. I get negative 8, and I have an 8 at positive 8f. Remember, you put the signs with it, and negative 2f squared. I do f times 4, positive 4f, f times negative 4f, negative 4f squared, and f times f squared, f cubed. And write it down, f cubed, combine like terms, so I'm just going straight down here, minus 6f squared plus 12f minus 8 for my final answer. 19 and 20, these are on the DCAS as well. They're written in function notation. So instead of like y equals, okay, they're written as function notation. This is what function notation looks like. Then f is the name of the function, and they can use any letter they want. The x on the inside is called the independent variable. This x has to be the same as whatever these variables are over here. Okay, so if I had all these were y's, then I'd have to say the f of y, just so you know. That's called the independent variable, that it has to stay the same. The name of the function can have different names out here. So that's the f function and that's the g function. Okay, and so it just says take the f function and add it to the g function. So I can just write an equal sign and add straight down. First I'm going to change my negatives to a positive. Positive times negative is negative. Positive times negative is negative. Okay, get it down there and just add straight down because the terms are already lined up. Like terms are lined up. So 6x squared plus 2x squared, 8x squared. Negative 6x, negative 6x, negative 12x. And 6 plus 2 is positive 8. And there's that answer. Now, 20 is multiplying the two trinomials together. Remember, we already did this problem. It's just not written like this, but we just did that right there in number 16. That's two trinomials multiplied together. Okay, so if you see that, you know multiply them together. If you see and written in function notation. That says f, that's a times sign, f times the g of x. They both have the x in them. Okay, so that just says multiply the two trinomials together. So again, if you want to do the box method, 3 rows and 3 columns, because I got two trinomials. First one, 6x squared minus 6x plus 6. 2x squared minus 6x plus 2. Go ahead and multiply your row by column. That gives me 12x to the fourth minus 36x cubed plus 12x squared. Negative 12x cubed plus, because negative has negatives, plus 36x squared and minus 12x. Then I have 12x squared minus 36x plus 12. Okay, there's only 1/4 degree, so 12x to the fourth. There's my two cubes, negative 48x cubed, combining like terms. Then this diagonal is my x squareds. 12 and 36 is 48, plus 12 is 60, x squared. And then I have negative 48x, and lastly a plus 12. Okay, now sometimes on the DCAS they'll have that full answer written out. Other times they'll have the fourth, the x to the fourth, x to the third, x squared, x, and the constant there, and then you would be putting in on the DCAS these coefficients, and then the last one being the constant. Okay, they might just have boxes like this, and you're filling in the boxes with those numbers after you multiply them together. So you'll get it in one way or the other. Either the full answer is written out, or you'll have boxes for the coefficients and the constant at the end to fill in yourself. All right, so that was test 1. Now we go to test 2 here. Okay, first one says state the solution to. It doesn't say state what that says. Several of you were stating what that says. So state the solution. Solution is subtract 2 across, and I get y doesn't equal negative 9. So I write that down. Y doesn't equal negative 9. I could have probably just written negative 9, the number itself, but set notation. Y bar, Y is all real, remember that's the all real symbol, except negative 9. And put the set notation again. Graphically, it says graph every number besides negative 9. So I just put a negative 9 there, put a circle so it doesn't include it, and shade it both directions. Number 1, or 2 now, solve for x. Remember, we combine like terms or distributive property. In this case, we have combining like terms right there. So you have x minus 7 equals negative 4x plus 1. I now ask myself, what side should I bring the variables to? Always the smaller to the larger. Negative 4 is less than 1, so we're going to add. Remember, we're going to move an entire term across. We're adding or subtracting. So, and we line it up under like terms. So that went there. Since the variable is going to the left, the constant has to go to the right. The opposite of negative 7 is plus 7. Okay, and I get 4x equals, that cancels out, 7 plus 1 is 8. Last step, divide by 4, and 8 divided by 4 is 2. I could check all these as I go through if I was right by plugging it back into the original equation. Number 3, we have distributive property and then combine like terms. Negative 6x minus 12 minus 6. Over here, there are no like terms or distributive properties, so I just write it down again. Combine these like terms. Negative 6x minus 18 equals negative 13 minus 4x. Now I'm back to asking the same question again. What side should I bring the variables to? Smaller to larger. So negative 6 is smaller than negative 4. Again, that's to the left. Negative 6 is to the net left of negative 4 in the number line, so it's smaller. Do the opposite operation. So the variable is going to the right, so the constant must go to the left of the equal sign. So the opposite of negative 13 is plus 13. Same rules over and over again. So 6x minus 4x is 2x. 13 minus 18 is negative 5. Okay, and those cancel out. And last step, divide by 2, and I get negative 5 halves. I do not have to change it to a um, mixed number. Okay, number 4, we have reverse PEMDAS. Solve them for x again, reverse PEMDAS. Add or subtract across an entire term. There's my entire term. Add or subtract across. The opposite of negative 4 is plus 4. So now I have 5x minus 5 over 2 equals 9. The left is a fraction. If I want the right is a fraction, I can go ahead and do that as a fraction. Then I have two ratios or two fractions that equal one another. It's called a proportion. And I cross multiply, set equal each other to solve all proportions. So 5x minus 5 times 1 is just still 5x minus 5. Remember, this is that butterfly, some people like to call it. You only do that with proportions, not with fractions or anything like that. Multiplication of fractions only with proportions. There must be an equal sign. And 2 times 9 is 18. Last step, we're back to, again, not last step, but now we're back to reverse PEMDAS. Add or subtract across, plus 5. 5x equals 23. And last step, divide by 5. So 23/5 is my answer. Okay, reverse PEMDAS again. Add the 6 across. And multiply by 5, the reciprocal of 1/5. Remember, the coefficient of that x is 1/5. It's the entire thing. It's not just that 1. The reciprocal of 1/5 is 5. Whatever I do to one side, I do to the other. So I get x is greater than 10. And then I want you to graph it. There's 10 greater than, put an open circle. Greater than is always to the right, shaded. Number 6, I can combine these like terms and get 21. Distributive property here. And I get negative 16 minus 4p. Okay, now I ask myself, what side should I bring the variables to? Remember, I want the variable always to be positive. Is the coefficient of p positive? No, it's not. So I'm going to move it across, which means the constant is going back the other way. So how do I move it across? Just add the 4p across. So I have 4p, and how do I get rid of the 21? Opposite positive 21, negative 21. Negative 21 and negative 16 is negative 37. Last step, divide by 4. So p is greater than or equal to negative 37 fourths. Okay. Now, I am being consistent. I was asking you to make the coefficient of the variable positive. So we're always dividing by a positive. Here's the problem for several of you that didn't choose to do it my way and you did it another legal way, but you forgot rules that have to apply with that. If I leave the negative 4 on this side and move the 16 across, subtract 16 across, then I'm left with a negative 4p. If I'm going to divide by the negative 4, which would be the next step, I have to then switch the inequality sign. Okay? That's what a lot of you forgot to do if you did it that way. See, if you do it my way, you're going to always be dividing by a positive, and you never have to switch the inequality sign. And remember that. On top of this, those that did it the other way, is sometimes you forgot to bring the negative down. And you just brought down 4p. And then that blew the whole rest of your answer. Okay, so there's multiple errors that can occur doing it the other way as opposed to doing it this way right here. You can still do it right if you do every step right. Okay, number 7. Combine like terms. X and 2x is 3x. So I have negative 3 equals 3x plus 5. I have myself as the coefficient of the x positive. Yes, it is. So it's going to stay there. So therefore, I'm moving the constant across. Remember, I'm always asking about the coefficient of the variable first. Constant, that doesn't matter till the end. Variable gets priority. So 3x negative 8 divided by 3, and I get negative 8/3. X is greater than negative 8/3. Okay, So negative 8/3 and greater than, open circle, shaded to the right. All right, okay, so here I've got the graph, negative 37/4. That's greater than or equal to, so it's going to be a closed circle there and shaded to the right. It's got an equal sign, it's closed circle. No equal sign, open circle. Number 8. Okay, number 8, I could distribute, or I could see that -2 goes into both. Well, remember, if I divide by negative, I have to switch the inequality sign so that less than becomes greater than. And now I have -5. Okay, so that's the one thing you have to remember if you're going to do that, is if you ever divide by negative, you have to switch the inequality sign or you're wrong. And last step, -3 from both sides. I get x is greater than -8. Since there's no room down there, I can put the -8 up here. Open circle, because there's no equal sign. Greater than is to the right. Number 9, we have a proportion again. How do we solve all proportions? We cross multiply. Why do I put parentheses around those two? Because they have more than one term. If I have more than one term, I need to have parentheses around it, so when I cross multiply, I remember to distribute. So I have 6 times the quantity n plus 1 equals 3 times the quantity n plus 8. Now distribute. 6n plus 6 equals 3n plus 24. I ask myself which variable coefficient is smaller. 3 is. So therefore I'm going to move the coefficient to the left. The opposite of 3n is -3n, which means the constant's going to the right. The opposite of +6 is -6. 3n equals 18. Divide by 3 and you get 6 for n. Okay? Now, as a side note, just so you know, you can never have 0 in the denominator. So if I want to put on the restrictions, I set the denominator equals 0 and n can't equal -1 when I solve it, and n can't equal -8. Because then I would get, if I had -8, I get a 0 on that one. If I had -1, I get a 0 on that other denominator. You can never divide by 0. So those are two restrictions he would have there. But 6 is not either one of those, so it didn't affect it. But if it came out to be -1 or -8, then there'd be no solution. All right, number 12. I'm solving for b sub 2. This is the area of a trapezoid, geometry next year. I have a fraction there. I can put this as a fraction. Cross multiply, and I get 2a equals h times the quantity b sub 1 plus b sub 2. I could distribute this through here. Get h b sub 1 plus h b sub 2 equals 2a. It has to remain as capital A. Lowercase a you get marked wrong. I'm solving for b sub 2. So I want to get rid of this entire term. When I get rid of an entire term across, I'm doing the opposite operation, subtraction. Remember, it's either addition or subtraction. Since that's already a plus, it's a minus. So I'm subtracting hb sub 1 from both sides. So now I'd have 2a minus hb sub 1 equals the hb sub 2 right here. Remember, I'm solving for b sub 2. So I need to get rid of this h. The opposite of multiplication is division. So I'm dividing both sides by h, and then that will equal b sub 2. 13, we're solving for y. Okay, so again, I look at the coefficient of y. Is it positive or negative? It's negative, so I'm going to move it to the other side. So I'm being consistent in everything I'm doing. And therefore, I'm subtracting that across. Come on. Where is it? I thought I hit. Okay. Okay, so I'm adding the 2y across. I'm subtracting the 3 across. So I have 2y equals 3x minus 3. And last step, divide by 2. Each term by 2. So y equals 3x over 2, or 3 halves x minus 3 halves. Okay. Number 14, solve. I subtract b across and then subtract the 2 to the other side. I get 0b equals negative 10. 0 times what number gives me negative 10? No number. So the answer is no solution. Number 15, explain and find the mistake in the work. Fix the error and find the correct solution. Well, I should know if I'm moving a term across, I have to do the opposite operation. That already says plus 3. They did plus 3 again. It should have been minus 3 at k right there. So if I did that, so should have, that'd be pointing out the error, should have subtracted 3k from both sides. Okay, so if it was a multiple choice question, that's what you would select right there. Should have subtracted 3k from both sides. Okay, so in doing that, I'd end up with 19 minus 5k, combining like terms, equals negative 1. Now I'm going to solve for k, so since that's negative, I'm going to move it back over to this side and add the constant across. So plus 1 here, plus 1 here, plus 5k, plus 5k. And then I get 5k equals 20. And last step, divide by 5. So k equals 4. That's the correct answer. All right, here, what's the error? I go step by step. Notice this 1/5 x became 1x. That means they had, in order to get 1/5 to 1, they had to multiply this entire equation by 5. That gives me 1x the next one. But then it shouldn't distribute properly. That's the 1x. I distribute this. That gives me 30. They don't have the 30 there. 3/5 times 5 is the 3x, but then they don't do 5 times 5 either correctly. That should have been 25. So didn't distribute 5 correctly. So it should have said x plus 30 equals 3x plus 25. That's the corrected one. Again, 1x is smaller, so I'm subtracting 1x across, always smaller to bigger. Since the variable is going to the right, the constant must go to the left. Subtract 25 across. And I get 2x equals 5. And last step, divide by 2. So the answer is 5/2. Okay, 17. Distribute 5x plus 10. Excuse me, 5x plus 1. When I subtract the 5x across to the left, because they're the same number, and the constant goes across, I get 0x equals 9. Does 0 times any number equal 9? No, so no solution. Here, subtract the 1 across, 3x equals 0. 3 times what is 0? 0 is. You could have also divided by 3 if you wanted to, and get 0x equals 0 that way. When I distribute this, there's no combining like terms are distributed on the left, so I just rewrite it. I get 2m plus 8 minus 4m. Combine like terms, I get 8 minus 2m equals 8 minus 2m. Notice those are the exact same. Whenever it's exactly the same, I can stop right there, but we'll keep going. I can stop right there. The answer is all real. Whenever we get the exact same thing on both sides. I can see that also because if I add the 2m across, which means the m's going to the left, the constant's going to the right, -8, -8, I get 0m equals 0. 0 times what gives me 0? Every number possible. That's why it's all real. Number 20, combine like terms. So that's a plus 2. Okay, that's all there is for combined like terms, but I have a fraction in my equation. So I want to multiply the entire equation by the common denominator, also called the least common multiple, and I get 5. That's it. So 5 divided by 5 is 1, times 2 is 2x. 5 times positive 2 is 10. 5 times 4x is 20x. And 5 times negative 5 is negative 25. Now I ask what side do I want the variables to go to? Smaller to larger. So the opposite of 2x, negative 2x. That means the constants going to the right. Opposite of negative 25 is positive 25. Okay. Gone, gone. So I have 35 equals 18x. Last step, divide by 18 on both sides. If this simplified, I would simplify. It does not simplify, so it's just 35/18. Remember, simplify does not mean change to a mixed number. It just means to simplify. If there's a common factor, you divide by the GCF, greatest common factor, on both numerator and denominator, and that would simplify it. All right, 21. We have, again, we're solving for x with an inequality. So first thing whenever I'm dealing with inequalities or x, even x's, so I'm solving for the x. I only have this one x term right here. Is the coefficient positive or negative? It is negative, so I want to move it to the other side to make it positive, which means the constant is going across. So I'm adding 2/5 x across, and I'm adding the 6 across. So now I have 2/5 x is less than or equal to 6 minus 2 is 4. Remember, I want to solve for 1x, so I multiply by the reciprocal. I'm trying to get rid of this 2/5. Whenever I'm trying to get rid of part of a term, I'm multiplying or dividing. If it's a fraction, I'm always multiplying by the reciprocal. 5/2. Whatever you do to one side, you must do to the other side. So now I get x, because these cancel. X is less than or equal to, this 2 cancels the 4 2 times. 5 times 2 is 10. So x is less than or equal to 10. Notice I move the x to the left side in the answer here, so but I still have to keep it the arrow pointed in the same direction. It's pointed to the x, and needs a point to the x there. So x is less than or equal to 10. Graph it, 10, and then it's less than or equal to, so it's a closed circle because it's equal to, and then less than is to the left. All right, a few more here, and we're done. 4 more than 2 times a number. 2 times a number is just x, or any variable you want to use. 2 times a number is 2x. 4 more than that means plus 4. And what is mean in math? Equals 48. And now they want you to solve it. So translate into the words into an equation, and solve it. Translate it into an equation. Now we solve it. Reverse PEMDAS. Subtract 4 across. 2x equals 44. Last step, divide by 2 on each side. X equals 22. Okay, you bought a magazine for $8 and 3 bags of Halloween candy for unknown amount. Unknown amount, again, is whatever variable you want. We'll say B for bags. So I have $8 plus 3 bags. You spent a total of $19. Okay, round to the nearest cent. How much did you pay for each candy bag there? So I need to solve it and then change it into 100 spot, nearest cent. So subtract 8 across, because again, the coefficient on the B is positive, so leave it there. 3b equals 11. Divide by 3. Okay, now this is one where you could change to a mixed number. 11 divided by 3 is 3 2/3. So that's $3 and 2/3 of a dollar. Well, if you know 2/3 of a dollar, that's 0.6 repeating bar. 2/3 equals 0.6. Now, if you don't know that, you just put in a calculator. 2 divided by 3 will give you 0.6 repeating bar. And I went to the nearest cent. So $3.67, because it's 6, 6, another 6. Since that's 5 or higher, it rounds up. So $3.67 per bag. Okay, last one. Find the length of each side. So what's the length and the width? We're going to fill in the length and the width. Okay. Now you need to remember, and this is the perimeter is 44 feet. This is the other given information. Random answer to the nearest tenth. So I need to remember hash marks, what they mean. That means those are congruent sides or equal length. So that's a 5x minus 2. Because I got one hash mark and then one hash mark. Those are equal lengths. So another 2x. Perimeter, you need to know from elementary school onward, is you're adding up all the sides. So I have 10x plus 4x is 14x. And a negative 2 and a negative 2 is minus 4. And it says that equals 44. The perimeter is 44. So I solve this, add the 4 across, because again, the coefficient on the x is positive, so I'm going to leave it there. I get 14x, x equals 48. And last step, divide by 14. Okay, so I need to divide that. So 14 goes in 48 3 times. That's 42 with 6 left over, 6/14, which would then reduce, divide each by 2, down to 3/7. Now you don't have to do all that. You can just put 48 divided by 14 in your calculator. Okay, and so that's what I'm going to do right now. I'm going to do 3. Well, I can leave it right now as far as exact because I only need the final answer in nearest 10th spot. So I calculate both of those. That's what x is. When I substitute that back in and a final answer, I'm going to put in the calculator. So length, it says 5 times, and that's going to be 21 plus 3 is 24/7. And then it says minus 2. So now you can type that in your calculator. So I can go 24 divided by 7 times 5 equals, and then minus 2 equals 15.1. Because remember, I'm looking at the next one over. That's 4 or less, so it's staying the same. 15.1 is what the length is. 15.1 feet. We don't forget the units. It tells me right here, feet. Okay, and now I just double that. So now I do 2 times 24/7. Okay, which then is 48/7. So I just type 48 divided by 7. 48 divided by 7. 6 point what? Since this is a 5 or higher, rounds it up. So it's 6.9. Okay, and I must add on the units there. 6.9 feet. Okay, so there is the answers for the length and the width to the nearest feet. Okay. All right. So that was the two tests and a quiz. And lastly, after that, we started systems of equations. I'm going to do 2 by graphing and then 2 by elimination because that's where we ended at the quarter. The next one is substitution. That's your homework. Remember, solving a system. So system of equations. What a system of equations means is I have 2 or more equations I need to solve simultaneously. Okay. So we're usually always dealing with 2 in Algebra 1. Okay. And what we're trying to find is find the point of intersection. And as we talked in class, also called the solution. So you need to know both terms, point of intersection and solution. Okay, so you need to remember that all y equals numbers is a horizontal line. Remember we tested on that in the first test already. It was y equal to numbers, such as y equals 2. It's a horizontal line at y equals that 2 right there. Okay, so if y equals 2, there's that. You can write y equals 2. Show me you know it's y equals 2. Now, number 1 is in standard form. And we talked about solving for y, as we've already done. We've done a whole, right before this, we did a solve for y worksheet. So you can put in slope intercept form. Okay, that's what most of you are familiar with. Okay, so to solve this for y, again, I look at the coefficient of y, it's positive, so I'm going to leave it there, which means I'm going to subtract the x across. Okay, now I have 3y equals negative x plus 3. Notice I switched the order. That plus 3 was first. So I put it last because we want it in y equals mx plus b form, slope-intercept form. Slope-intercept form, y equals mx plus b. So I want the x is the first term, the constant as the last term. Remember, that's standard form anyway, highest degree down. Last step, I divide each term by 3. And so I get y equals negative 1/3 x plus 1. So plus 1, okay, it says go ahead and go down 1 arrows. So slope is negative 1/3, down 1, right 3, down 1, right 3. Or I could switch the arrows because negative positive is negative, or a positive divided by a negative is also negative. So in that case, it'd be up 1, left 3. We talked about this. You need to be able to do both ways. So now look, if I go up 1, left 3, 1, 2, 3, it's right there on the line. Okay, now I could have just connected the first two and it would have intersected there anyway. But this one made it land right on the line doing that. So what is that solution or point of intersection? Negative 3. Remember, you always do the x coordinate first, and positive 2 for the y. So negative 3, 2. And of course, I could check that. Okay, y is 2. Yes, it is right there. Plug it in. Negative 3 plus 3 times 2. 3 times 2 is 6 minus 3 is 3. And I get it right. So I can check all these answers by plugging it back into both equations. It has to work for both. If it only works for one, it's not right. It has to work for both equations. All right. Here, I'm going to show you, you can solve for y again in these and do it the same way. But I'm going to also show you what you can do is if they're in standard form like this and they divide evenly, okay, I could also, this one, okay, I can also just do the x and y intercepts. Or x-intercept is when y equals 0. So if y is 0, 2x times 2x equals 50, x equals 25. It's not going to do me good here. Okay, so this is a little trickier one. Okay, but I'm just showing you if you wanted to, and it happened to work out. This one, you can't plot 25, 0 on this particular graph. The y-intercept is when x equals 0. So if x is 0, y is 5. Well, you can plot that one, 0, 5. So I'd have 0, 5. But notice the other one is 25, 0. Okay, so that's way off the graph over here. So, but I remember I need 2 points to make a line. So I can't use 25, 0, so I need to choose my own point here. Okay, let's say I make x 5. Let's make x 5. Okay, so it's going to be somewhere along here. X is 5. 2 times 5 is, so x is 5. We're going to put that in already. 10. 2 times 5 is 10. Subtract the 10 across. Then I get 10y equals 40. Divide by 10 on each side, and y equals 4. So 5, 4 is another point on the graph. The reason this is a good one is because there's a chance you're going to see one like this on the DCAS, where if you put it in slope-intercept form, I would get it, the y-intercept at, I wouldn't be able to graph everything nicely. Well, I would be able to in this case. So if I would have gone y-intercept form, it would have worked out nicely, and I would have got that right away. Okay, I was trying to show you a different way of standard form, but in this case, the standard form would have taken me off the graph. So if I would have solved this for y, I would have got that point and that point right away. Okay, but if somehow, and so this is actually good because if somehow your point wouldn't land you, your second point wouldn't land you on it, you need to be able to choose another x coordinate and then plug it in and solve for y, one that will land on the graph. So that made us do that right there. All right, so we'll solve the second one for y this time. So again, the coefficient is positive, so I'm going to subtract the 2x across. And so I have 5y equals negative 2x plus 20. divide by 5 on each term. Remember, they're called terms. So you get y equals negative 2/5 x. Remember, the coefficient of x is the negative 2/5, not negative 2. It's negative 2/5 plus 4. So positive 4, and it says negative 2/5 down to right 5. Or, or I can go up to left 5. Okay, remember, because I can switch the signs. So I could go up to 1, 2, left 5, 1, 2, 3, 4, 5, right there. Okay. The first one had a slope of negative 1/5, so I went up 1, left 5. That would have been right there as well. So both of them intersect. So if I do that one, that intersects there. Okay. And I do this one, and that intersects there. So remember, and the arrows at the end of the line showing it's a line, goes on forever. Okay, otherwise it's called a segment if you don't have those arrows there. It didn't say graph segments, it graph lines. Okay, so when you have arrows at the ends, I already told you you lose a point. So the point of intersection, that x coordinate is negative 5 and the y coordinate is 6. So negative 5 comma 6. Remember, the x always comes first, y comes second. Some of you were switching that. We saw several of you make problems and not being able to identify that point correctly. So you, on your paper, you could have graphed this perfectly right, as I pointed out to several of you who blew the point of intersection, but you didn't identify the negative 5, 6 correctly, and you get no credit on the DCAS, because getting multi-choice, you're filling negative 5, 6 is what they're looking for. So you need to be able to identify your points correctly. You also need to know your quadrants. To review, remember, this is quadrant 1, this is quadrant 2, this is quadrant 3, and this is quadrant 4. Okay, you need to have that memorized. Notice they're written in Roman numerals. Okay, so there's two examples of solving systems by graphing, and now we have two by elimination method. So, elimination method. Easy to remember. Elimination method means I want to eliminate the x's or the y's and solve for the other. In order to eliminate it, I need whichever one I choose, which to eliminate. Remember, I handed out these steps. Choose which to eliminate. Once I do that, then I determine, once I do that, okay, I need to make both coefficients of the one being eliminated to be opposites. Oops. Opposites. We'll do these steps one at a time. Then add both equations together. Which wipes out the one you're trying to eliminate. For solve for the one variable left. You just wiped out the one you chose to eliminate, one variable left. Okay. Fifth, substitute that answer into one of the equations and solve for the other variable. Now, technically, if you do everything right up there, you could be done. But to check, substitute both answers into the other equation to verify it is true. And if it is true, then you know your answer is correct. So you can know on every one of these problems if you have the answer correct or not. Okay, so we're going to go through those 6 steps right there, but you have to have those memorized. You were introduced to it last year in 8th grade. So we're going to do that for these 2 problems. Okay, so when I ask myself, if I want to eliminate the x's, I need to find the least common multiple. So what's the least common multiple or common denominator of 2 and 4? The answer is 4. So I'd make one a positive 4 and one a negative 4. Well, this already is positive 4, so then I'd make this top equation to negative 4. And how do I do that? By multiplying by negative 2. Negative 2 times 2x is negative 4x. I add it to the bottom equation. That gives me 0x. So it eliminates. So that was step 1. I chose to eliminate the x's. Step 2, I need to make the coefficients, one being positive, one being negative. They're opposites. So one's a negative 4x and one's a positive 4x. That was step 2. Then I'm going to add the equations. Okay, so some of you would have trouble doing this in your head, distributing and adding to the next equation down. So what you could do is go ahead and write it down here. I'm distributing, I get negative 4x, negative 6y, and negative times 46 is negative 92. Negative 2 times negative 46 is negative 92. Okay, now when I add down here, if you notice what happens here, I get 0x. Oh, y happen to wipe out as well. 0y equals negative 85. So does 0 times anything give me negative 85? No. So the answer is no solution. Okay, so I couldn't solve for the other variable. I couldn't solve for y because 0 times anything is not negative 85. So the full answer to that equation is no solution. What does a no solution mean? It means that the lines are parallel and do not intersect. Okay, because they can be parallel on the same line, or they can be parallel on different lines. If they're different lines, they're never going to intersect. So that's what it means when it's no solution. If it was all real, that means they're parallel on the exact same line. One is just called a multiple of the other. So we weren't able to work out all the steps there, but we will be able to do it on this one right here, number 3. Okay, so I could say, okay, I want to eliminate the y's this time. That's negative 3. And then top one, I need this to be a positive 3. And the bottom one here. Okay. So when I distribute this, notice I'm going to get positive 3y there to add with a negative 3y up top and eliminates the y's. Draw your arrows to make sure you distribute through all 3 terms. So now I have negative 27x plus 3y equals negative 57. And I can go ahead and rewrite this right below down here. 3x minus 3y equals negative 15. So again, that was step 1 and step 2. I chose to eliminate the y's. I got one to be positive, one to be negative. That's the 3y and the negative 3y. Now I add both equations together, so add straight down. I get negative 24x equals negative 72. That's step 3. I'll put that right there, step 3. Now we're in step 4, solve for the one variable left. Notice there's only one variable left, x. How do I solve that? Divide each side by negative 24. And then I get x. Now you get to remember, negative divided by negative is positive, and 72 divided by 24 is 3. So I solve for the variable left. That's step 4. Step 5 says substitute that answer, this x equals 3. So I'm going to substitute 3 in for x into one of the equations and solve for the other variables. It's my choice which equation I want to use. I'll just go ahead and use the top one. So then I'm going to have 3 times 3, because x is 3, minus 3y equals negative 15. Now, since I'm solving for y, see the coefficient of y is negative, I'm going to go ahead and move it across to make it positive and move the constant across over there. So then I'd have 9 plus 15, because I'm adding the 15 across, is 24 equals 3y. Last step, divide by 3, and y equals 8. Okay, so the point of intersection is 3, 8, and I write it as a point, x comma y. Now, step 6, remember, that's step 5. Step 6 is I want to check that answer by substituting both those answers, the 3 comma 8, that's both the answers, into the other equation to verify it's true. Okay, so now I'm going to plug it into the bottom equation. Do that right down here. 9, the x coordinate is 3, so I have 9 times 3 minus, whenever I substitute in, notice I put parentheses around it. Always put parentheses when you substitute in. And I substitute in 8. And does that equal 19 as it says? So I have 27 minus 8. Does that equal 19? Yes, it does. So I just checked it right there. So I guarantee that 3 comma 8 is the correct answer, which is the point of intersection. So if I was to graph those two lines, they would intersect at 3, 8. Now, just final discussions on this that I pointed out before in class. Remember the graphing method. We have the graphing solve systems by graphing, elimination. These are two we just did, and substitution is next that you'll be doing. Graphing is the least one used because remember, as I told you in graphing, you can only solve graphing ones if they end up being integer answers, which means they intersect at one of the corners. If it intersects anywhere inside a corner, that's a fraction or a decimal. You can't figure out what that is from the graph. But with elimination method and substitution method, you can solve for any answer, fractions, decimals, or integers. So elimination method and substitution method are the most popular ones, just so you know. So now in the DCAS, you'll have to do both, meaning graphing. They'll have you do one by graphing, and then you can choose, I think, elimination or substitution for the other one. Okay, but you do have to know how to graph lines. Okay, so you gotta be able to solve for y, for example, put in slope-intercept form as we did up here. Okay, and graph the lines correctly. All right, so that answers or goes over everything that we just went over in quarter 1. Hour and 22 minutes.